Good morning, everyone, and welcome to our very first hashtag weather break with Storm Team 8. I'm meteorologist Lee Spann.
And I'm Ian Oliver.
And we know that the kids are home from school. They're going to start getting their online lessons for most people next week. So we wanted to use this week to give you a little weather lesson every day at 10 a.m.
Why not? It's a good opportunity to talk a little bit about weather, have a little fun with weather learning, which of course we have very unique weather here in Tampa Bay, and we have some time to talk about it.
Yeah, and so our JB Buno is going to be monitoring our Facebook Live. So if you have questions, you can type them there. If you're watching on the app, you can use the hashtag weather break on Facebook or Twitter. Send your questions in. We want this to be really interactive. And we want the kids to learn something, and maybe, I don't know, maybe the parents learn something too.
Yeah, and it's the first one. You're going to start talking about weather. You got to talk about clouds.
Clouds, right? So there are 4 types of clouds. The cirrus clouds, which look a little bit like hairs in the air. They're very thin. They're made out of ice crystals, and they usually bring absolutely no rain. Right.
These are very high up in the atmosphere, and they really just decorate the sky pretty much. They don't do a whole lot besides that. Weather forecasting for us, it's all about nailing down which type of these clouds we're going to see. We live in the Sunshine State. It's actually the sun that generates the clouds. And we'll show you that coming up.
Yep, so we have, and the other types, cumulus clouds, those are the ones that are a little puffier. We have the stratus clouds, look kind of like a blanket in the sky sometimes, and then these. You want to tell them a little bit about cumulonimbus clouds?
We know a lot about these. These are the most, we call it vertically developed, which just means that they build way high up in the atmosphere. These we look at developing all the way up to about 10 miles in Florida. That's why it still blows me away, even doing this for a long time. You walk out of the TV station, you see a cumulonimbus cloud off in the distance. I'll check my Max Defender 8 app, and you'll see it's a thunderstorm offshore of Sarasota.
Yes.
We can see these things for so far away because they're so tall, but because they're so tall, they can generate very heavy rainfall and a lot of lightning.
So those are the types of clouds, but we're going to talk a little bit more about that at the end of the lesson and even give you an activity to do with your family. But first, we're going to tell you about how clouds develop to begin with. And it all starts with the sunshine. In fact, that's how a lot of weather develops, because you start to get a little excess heat somewhere or somewhere else. So this is specifically that the sun heats the earth during the day. So the earth is actually what ends up warming up. The air doesn't warm up. The earth warms and then begins to, that heat rises.
Right, then we call that instability. In order to generate clouds, you have to have air that's being lifted. Oftentimes, it only takes warming from the sun to get air to rise. Sometimes, the winter time for us, or even in the summertime with the sea breeze, you have a frontal boundary that actually physically lifts the air, and that generates cloud cover as well. That's typically when you would see the stratus cloud deck, a large layer of air being forced up, as opposed to convection, rising air, when you see those puffy cumulus clouds that keep on growing and growing and eventually grow into thunderstorms in the summertime.
And a lot of weather also based on the fact that warm air rises. So what happens is the warm air rises to what we call the condensation level. Now, you know that as the stuff around your glass, whenever you put ice cold water inside the glass, all of a sudden it looks like the glass is sweating. It's not that the water is coming through the glass by any means. It's the fact that the glass got cold and the moisture in the air outside of the glass condenses, condensation level, and creates that sort of water droplets all around your cup. So that's exactly what this is.
So you can pretty much call the condensation level the bottom of the cloud.
Bottom of the clouds. You'll see it a lot of times. I mean, they'll be very flat.
Yep, and then from there the air keeps rising, and that's the vertical development, the tallness of it that I was talking about. So at the surface you have very warm air that has moisture in it, humidity.
We feel that.
Yes, very much so. And as it rises, it expands and cools. And as it does so, cold air just can't hold as much moisture. We call that saturation. So once the air becomes saturated, the water that's in the air, which exists as a gas, has to get squeezed out into liquid water. That's what condensation is. That's the process.
And that's what we see as a cloud.
Right.
So it comes from being an invisible gas, which is water vapor, to tiny, tiny water droplets in the air, and that's where you can start to see them. But when they start to get bigger and bigger, those droplets get bigger and bigger and bigger, what happens? They fall.
Right.
And what is that? That's where you get your rainfall. So you got 3 stages of development with clouds. The first one is when you start to see the clouds pop up. And then we know what they look like in the middle. big thunderstorms, rain is falling, and then we have dissipating stage. So we'll go through each of those stages for you. Of course, we talked about that upward motion. You can clearly see it here, creating those clouds, helping to form the cumulus clouds, where we haven't seen many of those cumulus clouds even here recently. It's been so dry, because you actually need some moisture in order to get that. I think we'll get a little bit more of that this week.
It's stable atmosphere above us, and this is a good time to point out, a lot of times in the summer when we have a stable atmosphere above us, of course it's a whole lot muggier. We can generate the showers and thunderstorms, but sometimes they're only around for 20 minutes, 30 minutes. It's an updraft, it's a downdraft, and that's it.
And speaking of those updrafts and downdrafts, that's what happens in our next stage, and that's where you get mature. Oh, let's go. We got to go back.
Wait a minute.
Like I clicked twice.
Don't look at that. That's tomorrow.
That's tomorrow's lesson. So you have the cumulus stage, and then after that, the clouds begin to get bigger and bigger. And so you have air coming into the cloud, and you have the downdrafts. And that's where the rain starts to fall. You get that kind of cool wind out ahead of it. Keep in mind, some of that downdraft is coming from the tops of the clouds, as high as mountains, and then it comes down, and it's a lot colder. You feel that a lot in the summer. You think, oh, that feels nice, and you might know that the thunderstorm's coming. Something
about clouds that totally blew me away when I learned it is the scientific term is cloud condensation nuclei. Basically, for water to go from a gas to a liquid, it needs a little something because of the properties of water. It's dirt and dust in the atmosphere. They're very, very tiny that we're talking about, but it gets blown around into the updrafts, the general flow of the atmosphere above us, and that's what the water condenses on. So really, if you stick your tongue out and you drink some raindrops,
you shouldn't probably do that.
There's a little bit of dirt in there. It's like 1/100th of a raindrop. It's small, but
minuscule part.
There you go.
Yes, you need a condensation nuclei for all these water droplets to start to condense and coalesce with each other. And then when they get too heavy, they come down, and that's the mature stage of a thunderstorm. And then finally the dissipating stage, and that's where it's all downdrafts. It's not developing anymore, and it'll sort of. I always say it just rains itself out. Like all the moisture comes down, and we're done. That's the whole cloud formation.
We could use a cloud to rain itself out above us.
Yeah, this is typically our dry season, but it's been extraordinarily dry. So I'm going to check in with JB Buno. How many fun questions have we gotten today?
We have a lot of comments here, and hello there, everybody watching on WFLA's app, WFLA.com, and WFLA's Facebook page. We're live here in the Stream Center with Lee Spann, Ian Oliver, myself. We have some great comments coming in. Scott Robinson says, thank you guys. He's watching from South Korea. That's where he says he's watching from. Doris Moore and Charles saying good morning from Orlando. Teresa Johnston saying watching from my kids, excited to learn about the weather. So really neat that we have people coming in from really all over the world. Nicole Merritt says that her kids, Peyton, Weston, and Harper, are watching from home, and they want to know why clouds move, Lee and Ian.
So wind at the surface and up in the atmosphere can be different directions. And so sometimes you may see a cloud going one way, but you feel wind going from a different direction. So it's all about the wind direction as you go up in the atmosphere. And
that plays a huge part in our weather forecasts. You take any day in the summer, for instance, you have the sea breeze, which is a feature that's happening fairly close to the surface. We could have a west wind that's coming in off the Gulf of Mexico, but you look up, and the prevailing wind direction, you actually see the clouds moving from the east to the west, and all of that plays a factor when you get showers, when you get thunderstorms to develop, which direction they're going to move, because they're being basically pressed at we talked about a thunderstorm being 10 miles tall. Sometimes we have a shearing effect where at the low levels the storm is being pushed to the east, and at the top that's why you see those anvils sometimes getting pushed. We had a thunderstorm, and then an hour later we get that kind of milky sky, because you have cloud cover way high up in the atmosphere. That's basically the top of a thunderstorm that's getting pushed off.
So while we feel wind here at the surface, again, you have to think the atmosphere, one of the big things about it is that it is three-dimensional, and it is not always the same. So if you're, pilots have to think about what the weather is like, 65,000 feet above us. And so that's important, and that's what actually helps to drive those clouds, because the winds are much stronger higher in the atmosphere as well, and that can push them one way or another. Any other questions?
Yeah, we have a few more coming in. Yeah, we have a few more coming in, you guys. I see here that that Amanda McCartney is watching with her 6-year-old and wants to know How high up is a cloud? We have another question here that we'll check back in here with you guys momentarily. But Amanda McCartney and her 6-year-old wanting to know how high up in the air are clouds?
Well, the first thing you have to know is where that condensation level is. And that's actually a very important part of meteorology, is to find out where that is, because sometimes it's down here almost at tops of buildings, and that's where you get sort of those low hanging clouds. So you know where the clouds start. That could be anywhere where that condensation level is. But as Ian has mentioned, it could go way high.
Yeah, we like to think it's easier. We take a thermometer, we measure the weather conditions at the surface, but the temperature profile and the moisture profile of the air above us, this is a very tall atmosphere, and it's not uniform.
Right.
That's why every day, multiple times a day, twice a day, the National Weather Service office in Ruskin takes a weather balloon with very exact instruments on it that measures the weather conditions all the way up through the atmosphere. Those weather conditions get ingested into our forecast model, so not only in the short term, but in the long term, we can make our weather predictions for the 8-day forecast.
So to answer your question, how tall are they? It all depends. Every day they're going to look different. They could start lower, they could start higher, they could go higher, they could be pushed down to be, so it all depends on what the weather is that day. And that's actually part of our job, is to decide how tall those clouds are going to get, because that could mean how bad the thunderstorms are going to get because of it.
We usually have 3 tiers of clouds. So we have low clouds, we have mid-level clouds, and we have upper-level clouds. So the low clouds is probably at the surface, fog, all the way up to about maybe 6,500 feet or so. Then you go up 6,500 to about 25,000 feet, which we're talking at that point a mile to 5 miles up.
Where planes fly.
Right.
Way higher than, I mean,
and then the thunderstorm clouds, where you get the clouds that are made up mostly out of ice, which is kind of wild to think about. Solid ice, it's just very small amounts being suspended way up in the atmosphere. That's the wispy clouds you see, cirrus clouds.
So we'll take a minute to show you what it's going to be your project for the day.
This is elite level arts and crafts. Look at this.
I did this yesterday, and if I can do it, kids, I know you can do it. And all it takes is some sort of piece of paper. I happen to have this at my house already, green poster board, and cotton balls. So as Ian was saying, we have different levels of clouds. Now these cirrus clouds, the ones that look like, just kind of like a cow's tail, wispy, like a horse's tail or hair-like. So you want to do with your cotton ball is just stretch those out, put them as skinny as possible, and you can either use some glue or some tape those right on. And cumulus clouds, you want to tell them what they look like?
Those are the little puffy ones. We see those almost every day in the summer. We've seen a few of those around. A lot of times at this stage of development, they don't produce any showers. They just look kind of nice on the blue sky. Those happen generally in the low, sometimes up in the mid-levels of the atmosphere.
And then we have stratus clouds. Now those are the ones that can be where it's completely overcast and it looks like a blanket. They're not really tall. They just sort of makes it kind of a murky day. Now they could have some breaks in them, but the general stratus clouds are just a layer of thin clouds, and that's what we're seeing here. I actually was able to roll out my cotton ball and make the stratus cloud. So however you want to make your blanket-like clouds, that's a stratus cloud. And then the cumulonimbus cloud.
And look how angry Lee made this look.
Very angry.
Is this a magic marker? How do we do this?
I was going to use a Sharpie, but then the cotton kind of stuck to the Sharpie, so I ended up using a fabric marker that I had. So, but anything, you can even use spray paint, you can use food coloring, whatever you can, you got to make them angry.
Sharpie's permanent too. We're up in the danger level at that point. That's problematic. But yeah, cumulonimbus, this is the type of clouds we would see producing rainfall and lightning. This is a pretty common cloud formation that we see just 150 days a year in Florida, something like that.
So if you make your cloud type poster board, I would love to see it. Again, you can always use the hashtag weatherbreak. Or you can put it on my Facebook page or Ian's Facebook page or WFLA's Facebook page and just hashtag weatherbreak cloud type. So that's your homework for the day, kids. It should be a little more fun than maybe your typical.
Set the bar very high too.
All right, JB, any other questions coming our way?
Yeah, I just want to give some shout outs to some folks that are joining us here on Facebook Live, like Kristen Cohen. April Gray is watching with her grandson there, Lucas, 6-year-old Lucas. Danielle, watching with her 6-year-old son, Adam. Really quickly wants to know how fast clouds can move. We don't have too much time left, but how fast can clouds move, you guys?
Short answer is really fast.
Really fast. Those upper level winds can be,
You get up in the jet stream up to 180, 200 miles per hour. If you think about how fast cars go at Daytona, there you go. That's how fast clouds can move.
That's a good example.
Upper level clouds can move. Not here at the surface, but way up in the atmosphere.
Kristen Cohen watching with Lucy, who is 7 years old.
Hi, Lucy.
Sarah watching with her kids from home. Sarah Cousins, a WFLA Top Facebook fan. Dana Nance is watching here. And then the one comment that I wanted to get to, Allie Slager is watching with Ray Lynn, who is 4 years old. And I'm trying to find that comment. There it is. Raylan wanted to know, why is thunder loud when it rains?
That is a good question.
Why is thunder loud? We only have about a minute left here, you guys.
This will be real fast. So lightning is 10 times hotter than the surface of the sun. But it only lasts for like that moment, right? And it's so hot that the air around it explodes.
Pretty much, yeah.
It just explodes the air. The air gets so hot so fast, you have a big explosion.
Yeah, and the sound, you know, we talk about there's no sound in space. All those air molecules basically slam into each other, and it creates almost like a sonic boom that originates from that column of air that got superheated, spreads out in every direction, bouncing into all the air molecules from where it happened all the way eventually into your eardrum, and yeah, it sounds really loud.
That has concluded our weather break, our very first one. Thank you to everyone who tuned in. We hope that we can talk to you every day at 10 a.m. while we're in sort of this new normal that we talk about. So you're getting distance learning, e-learning a little bit early for most of you. But thank you so much for tuning in.
Thanks for being with us. This is fun.
Yeah, so we'll be back tomorrow with more #weather break lessons.